Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 1 from the October-November 2021 International A-Level. This is the Cambridge Paper 4 Variant 2, which is a mechanics paper. And this is from the 9709 syllabus. And this question is about, as we can see, a velocity time graph, which models the motion of a car. The graph consists of 6 straight line segments, 1, 2, 3, 4, 5, 6. The car accelerates from rest to a speed of 20 meters per second over a period of 5 seconds, and then travels at this speed for a further 20 seconds. And the car then decelerates to a speed of 6 meters per second over a period of 5 seconds. The speed is maintained for a further t minus 30 seconds. Okay, so t minus 30 seconds. All right. And then the car accelerates again to a speed of 20 meters per second before, in a period of 50 minus t seconds, before decelerating to rest over a period of 10 seconds. Okay, so given that during the 2 stages of the motion when the car is accelerating, which is in this one and this one, the accelerations are equal, find the value of t. Okay, so first of all, we got to find the acceleration in this first section. And the acceleration in the first section is the change in y over the change in x. The acceleration on a speed or a velocity time graph is given by the gradient of the graph. So we need to find the gradient of this section here. So we have this point, which is 5, 20, and this point, which is 0, 0. So the acceleration is going to be, okay, the acceleration is going to be 20 over 5, which is 4 meters per second squared. And that's the same acceleration over here. So the gradient of this section is the same. So here we have the point 50, 20, and here we have the point t and 6. So I know that the gradient of this line is the same. So I can say 20 minus 6 over 50 minus t is equal to 4. So I can say that 20 minus 6, the change in y, over the change in x, which is 50 minus t, is equal to 4 meters per second. So I can rearrange this. This gives me 14 over 4 is equal to 50 minus t. I'm just multiplying both sides by 50 minus t and just subtracting that. So you end up with t is equal to 50 minus 7 over 2, 50 minus 3.5. So t is equal to 46.5 seconds. T is equal to 46.5 seconds. That looks just right to me. Good. All right, that's part A. Then it says, part B, find the total distance traveled by the car during the motion. So the total distance traveled is the area under all of these shapes. So we're trying to split them up now into shapes which will be easy for us to work out the area of. So I'm going to look for trapezium shapes. I don't want to have so many shapes, so I'll look for trapezium shapes, and there'll probably be some few triangles in there. So for example, if I make a line here, in fact, you know what? If I make a line here, that's probably the best to do. That's the best thing that we could do here. Make a line here up to this point here, I think. Okay, if we make this line, how does that help us? We have one big rectangle down here. In fact, we have one big trapezium down here. Okay, so from there we have this trapezium. Okay, and then we have another trapezium, this whole thing, and then we have this triangle and this triangle. I don't know if that's the best way to do it. Well, maybe there's probably other ways. We could have gone this way as well, but I think there's too many. We'd have a trapezium here, and then we have a trapezium here, then we have a rectangle here, and then we have a trapezium here, we have a triangle here. I think this is better. Okay, so we have this one big trapezium, okay, which I'll just make outline for so it's clear. So I have this big trapezium here, okay, all the way. If I make it to there with that, but then you have to find what that, yeah, this is better. I want to find it such that I know all the lengths easily. If I make it to there, then I have to find out what that length is. That's going to be a bit of hassle. I don't want hassle. I want to make life easy. So now we're going to also think about this trapezium here, which I'll put in a different color. This is another trapezium. Okay, I'll put the red line slightly above that. Okay, so you have another trapezium here. That's the second trapezium. Okay, and then we have a triangle here. Now, I'm a bit colorblind, so I don't know. I'll just put any random color. All right, so you got this triangle here. You know what? I just thought of something even easier. Let's get rid of all these lines. Let's have a look. So the easy thing to do here is, I think, to just take the whole area of this whole big trapezium. So I'm going to take, oops, make that a bit smaller. So I'm going to take the area of the whole trapezium. Okay, sorry about this. I just thought of this, the whole trapezium. I mean, like, make it into one huge big trapezium, even the parts that we don't want. That's one huge big trapezium. Okay, and then we only have, so that we can find the area of that trapezium. That's not a big deal. We got all the lengths that we need. And all we have to do now is take away this trapezium from it. That's much easier. So if I take away this trapezium, okay, if I take away the area of this, smaller. If I take this area away, okay, from the whole thing, because I have the area of under all of this, take away that makes life so much easier. Okay, so to find the area of a trapezium, what we need is the distance between the parallel sides, and we need to have the length of the parallel sides. So in this case, this big trapezium, the distance between the parallel sides is 20, and the length of the parallel sides, well, you have this length here, which is between 50 and 5, which is 45. Okay, and you have this distance here, which is between 0 and 60. Okay, so we can find the area of the big trapezium very easily. Okay, and for the little trapezium, we have the distance between the parallel sides. The distance between the parallel sides here is this distance here, which is going to be between 6 and 20, so that's 14. And the length of this parallel side is between 30 and t. What was t? T was 46.5, so that's going to be 16.5. This is 46.5, if you remember. And then on the top here, between 25 and 50, that length is 25. So we have everything we need. That makes life so much easier. Okay, so for the big trapezium, we have 20 over 2 times 45 plus 60. So we have 20 over 2. Let me just change the color of the pen. Okay, so we have 20 over 2 times 45 plus 60. That's the whole area, minus the area of the small trapezium, which is 14 over 2 times 25 plus 16.5. That's going to be minus 14 over 2 times 25 plus 14 over 2, 25 plus 16.5. And that will give you the area in a very quick, simple way. So we can just calculate that. We have, that's going to be 10 times 105. Oops, 10 times 105, right? Because that's 10, that's 105. Minus 7 times 25 plus 16.5. 7 times 25 plus 16.5. Take away, yes, good. So that gives us 759.5, 759.5 meters. And there's the answer. And that concludes question number 1. So sometimes it's good to just have a quick look and check how is it, simple. What's a simple way of us finding this area? It's just basically this big trapezium, this little trapezium taken away from the big one, instead of splitting up into lots of different shapes like I was thinking about first. Sometimes it's good to take a step back and try to think of an easy way of doing this to save some time. So there we have it, the question number 1 answered. Other questions from this paper can be found in the playlist that will appear in this top right of the screen at the end of the video. Other questions from the topic of travel graphs and velocity time graphs, speed time graphs, and so on in the playlist at the bottom over here. You can subscribe to the channel by clicking on this link. And at the top here, you can find a video explaining to you how to use my channel. Thank you for watching and see you soon.